Good morning, math masters and math wizards, and welcome to yet another edition of Mr. Leggett's Eureka Math in the Morning Time. Okay, we'll be taking the third caller. No, we won't. Okay, believe it or not, we are still adding mixed numbers. And remember, a mixed number is a number that has a whole number and a fraction. So our very first one we're going to tackle is 3 1/3. And we're going to add to that 2 2/3. Well, we all know from way back when that 3 plus 2 equals 5. So I'm going to put a 5 right there. But now what about this? Well, let's add that to the equation. We know the denominator stays the same. Right? Math Mutt tells us that all the time. And we just have to add the numerators. 1 plus 2 is 3. So now look what we have here. 5 plus 3/3. What do 3/3 equal? Time for the old tape diagram. We're going to make 3 units. 1 unit, 2 unit, 3 unit. What we're adding here is 1/3 and 2/3. What do we get? We get 1, 2, 3/3. 3/3 is 1 whole. So now we can take this equation up here and just do 5 plus 1. What does that equal, ladies and gentlemen, boys and girls, damas y caballeros? It equals 6. And there we have it. Problem number 1 of 6 in the books. Let's continue on to our next problem, which is 4 1/4 plus 3 2/4. What will that equal? Well, let's kind of tackle this problem the same way we tackled the last one. And we'll say 4 plus 3. What is 4 plus 3? 7. So we'll put a 7 right over here. 7 plus what? Well, we know the fourths do not change. The denominator remains the same. And then go 1 plus 2. What's 1 plus 2? That's 3. So now we're left with 7 plus 3/4. Well, I think we know fractions well enough now that that will equal 7 3/4. So we'll put another equal sign down here. And 7 3/4 is our answer. Notice that 4 plus 3 is 7. 1/4 or 1/4 plus 2/4 equals 3/4. 7 plus 3/4 is 7 3/4. Problem number 3. What we're dealing with here is 2 2/6 plus 6 4/6. I'm going to put that problem down there. So let's dissect this the way we did the others. Let's add our whole numbers. 2 plus 6, 6, 7, 8. So we have 8 plus what? We need to add on our fractions. Now the denominator we know stays the same. That's not changing. We don't go 6 plus 6 is 12. No, we don't do that. But we do go with the numerator. 2 plus 4 is 6. 4, 5, 6. And we have 8 plus 6, 6. Well, we know by now, I hope, if I'm doing my job and you're doing your job, we know by now that if the numerator and the denominator are the same number, that they are indeed equal 1 whole. It could be 1,022 here and 1,022 there, and it would equal 1 whole. So, this is 1 whole, and that makes it 8 plus 1. And you could ask your little brother or sister in first grade to tell you what 8 plus 1 is if you need to, because they would tell you it is 9. So notice 2 plus 6 is 8. 2 6 plus 4 6 is 6 6. We know that 6 6 equals 1 whole. 8 plus 1 equals 9. And there you have it. Now, I often tell you that Eureka is a Latin phrase that when translated into English means I have found it. And what have we found? Well, we have found the best way to learn math. And another thing we've discovered about Eureka is that the problems tend to get more difficult as we work our way into the problem set, and that is just what is happening. So, follow along, because we're about to get into a little more murky water. 2 and 4/6. Excuse me, 4/5 plus 1 and 2/5. Now, Princess Yvonne can tell you right away that these fractions will no doubt, be an improper fraction, because I know that 4 plus 2 is 6, and the denominator, it remains the same. So it will be improper fraction, I believe. Well, I believe you're absolutely correct, Princess Yvonne, but let's prove it the Eureka way. 2 plus 1. 2 plus 1 is 3. We're done with these guys. We still have to add these fractions, right? Math Mud has told us time and time again that the denominators, when we're adding like this, when the denominators are the same, and we are adding, that they simply do not change, Mr. Leggett. They remain the same. Yes, Math Mud, they remain the same. So the 5 is going to remain the same, but we add the numerator, 4, 5, and 6. So now we have 3 plus 6/5. But what is 6/5 all about? Well, we're going to break it down in a number bond. And we're going to do one whole, 5/5. Remember, same numerator, same denominator, equals 1. What's left over? Well, we have 6/5, 5/5 here, so 1/5 is left over. And I bet you're saying to yourself, well, Mr. Leggett, I know this is 1 and 1/5. Yes, that is correct. However, we're going to prove it using the number line. And this is how we use the number line. We're going to start off at 2, and we're going to go to 3. And we're going to go to 4, and we're going to go to 5, and there we have that. So what unit are we going to break these into? Fifths. Right. 2 and 1/5, 2 and 2/5, 2 and 3/5, 2 and 4/5, and 3. 3 and 1/5, 3 and 2/5, 3 and 3/5, 3 and 4/5, and 4. 4 and 1/5, 4 and 2/5, 4 and 3/5, 4 and 4/5, and 5. So now where are we going to start? Well, let's start at 2 and 4/5. Ding, 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 ding. We could start at 2 and 4/5. There's a couple of ways we can approach this. You know what? Let's do it this way. I'm going to cross that out. Let's start at 3. Why make things confusing? We're going to start right at 3, and all we're going to do is we're going to add 6/5, right? Because we got to 3, 2 plus 1 is 3, now we need to add 6/5. 1/5, 2/5, 3/5, 4/5, 5/5, 6/5. Boom! And there we have it. Plus 6/5. What do we get? We get 4 and 1/5. So this equation, 3 plus 6/5 equals 4 and 1/5. Oh, that little tiny fifth. Alrighty, let's keep on rolling. And let's do 1 and 3/4 plus 3 and 3/4. And this is going to be kind of a we do. And you know where we work together to do this? But since you're not with me, I'm going to call on MathMut to help me with this problem and walk us through it step by step, okay? I like that idea. Good, I'm glad you do, MathMut. MathMut, I'm going to throw out the questions and you're going to give me the answers, okay? Okay. All right. Well, let's look at it. What do we need to do first? Well, the first thing I would do is add 1 plus 3. And that would equal bark, 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 bark. Yes, it would equal 4. 1 plus 3 is 4. MathMut, what would you do next? I would add the fractions. Yes, and what would we get? Well, denominator remains the same, as I've said many times before. Yes. So the denominator remains a 4. And then we simply add the numerators. Yes, and what are the numerators? 3 and 3. 3 plus 3 is 6. 3 plus 3 is 6. Yes, 3 plus 3 is 6. So now we have 4 and 6/4. What do we need to do now? This is improper. We need to make improper fraction into mixed number. Yes, we do. So let's get right away. That's the number bond. So what do we need to do? What do we need to do, Matt? I know you're excited, you want to talk. We will make one whole, which is 4/4. Yes. And how many fourths are left over? Well, just 6 minus 4 is 2, so 2/4 are left over. Yes. So now we have 1 whole and 2/4. Exactly. Should we do a number line to see what's going on? I think a number line would be very helpful. All right, let's do it. Thank you for holding down the paper. You're welcome. So we're going to start off with 4, and we'll go to 5, and then 6. Yes, 4, 5, 6. What unit should I break them up into, into fourths? 1, 2, 3, and 4. Oops, that wasn't very good. No, it wasn't. 1, 2, 3, and 4. So you have 4 and 1/4, 4 and 2/4, 4 and 3/4, 5. 5 and 1/4, 5 and 2/4, 5 and 3/4, 6. Yes. So let's start out at 4. Because there's our 4 right there. So 1 plus is 3. Yeah, then we're going to add 6/4 to it. Are you ready? Yes, I'm ready. 1, 2, 3, 4, 5, and 6. So we added 6/4. 1, 2, 3, 4, 5, 6. Boom! And we're going to add 6/4. And there we have our answer. What would it be? It would be 5 and 2/4. Yeah, 5 and 2/4. We took our 4 up there and we added 6/4. 1, 2, 3, 4, 5, 6. And we can also see that it's 4 plus 1, which is 5, and plus 2/4. So it's 5 and 2/4. But what I'm going to put down is this. 4 plus 1 and 2/4 equals 5 and 2/4. Yes, thank you, Math Mutt. You've been a tremendous help. I especially enjoy how you explain the denominators. Thank you, Mr. Levy. All right, this is a you do. And you can either try this by yourself or work it with an adult at home or an older brother and sister. 3 and 3/8 plus 2 and 5/8. Now, I want you to, oh, no, that's too easy. I thought it was too easy. 2 and 6/8. That'll make it a little more difficult. So now what you need to do with this video is you know what's coming. You know who's going to make a scene here. It's time to pass. Okay, welcome back. Well, let's see what you did here. We know that 3 plus 2 is 5. And we know that the 8 does not change. And then 3 plus 6, 6, 7, 8, 9. So we have 9/8. What can we break 9/8 into? We would do the 1 whole, which would be what? 8/8. And how many 8s are left over? If we had 8/8, well, there's 9/8, so we have 1/8 left over. That's it. Now, let's do the number line. And what we're going to do is we're going to start off with 5. 5, 6, and 7. What do we need to break these into? We're dealing with 8s, so we need to break them in 8s. 5 and 1/8, 5 and 2/8, 5 and 3/8, 5 and 4/8, 5 and 5/8, 5 and 6/8, 5 and 7/8, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. So there we have our 8s. We're going to start off at 5. And look what we're going to add to it. 9/8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go plus 9/8. Where do we find ourselves? Well, we find ourselves at 6 and 1/8. Yeah, you bet we do. So we can do it this way, but we can also go 5 plus 1 plus 1/8, right? So 5 plus 1 is 6, and we have the 1/8. Yes, that was a fun math lesson. I think it was anyway. And make sure you log on to Imagine Learning in IXL, and make sure you check out Language Arts. We're starting our new week, and I hope you had a wonderful Memorial Day weekend. I know I did. And that's it. So we will see you tomorrow, which will be Wednesday.